Hello my kiddos, this is Miss Allen again. Today we're going to be discussing speed, velocity, distance, time, and acceleration. Okay? So these are just going to be some quick notes. And what I'm going to do now, I'm just going to take my pen or pencil. We don't have to use a ruler. And we're just going to separate it, okay? Now, you do not have to go all the way down. So I'm just separating between speed, velocity, distance, time, and acceleration is good. It's at the end. So, starting with speed. The first thing I want you to know is speed. It basically answers the question, how fast? Okay? It answers the question, how fast? Now, these terms are not new, of course. We're just going over it a little bit deeper. I just want to make sure you understand the quick and easy facts first, okay? But speed answers the question, how fast? In speed, it looks different in a multitude of ways. It can be miles per hour. It can be kilometers per hour. Oops, why did I put an I? Per hour. It can be meters per second. It can be miles per day. It can be inches, and you see I have a multitude of ways, right? And these are not the only examples, of course, but it can be inches per second. And basically, whenever you see distance over time, you guys, some form of distance over some measurement of time, that is going to be speed. Okay? Super easy. Now the next one is velocity. It's the same thing as speed, except, so it answers the question, how fast? But the only addition is, it includes a direction. So how fast with direction. And make sure you're copying this down, okay? So, same thing as speed, it can look a multitude of ways as well. So you have miles per hour, but not just miles per hour, we have to have a direction, right? So it can be miles per hour going west. It can be meters per second going north. It can be kilometers per hour going south. Like I said, it's the same thing as speed, so it's going to be distance. Whenever you see distance over time, but this time we have a specific direction. So distance over time with direction. Now let's go ahead and put a little cloud bubble around there. The next one we're going to discuss is distance. It answers the question, how far something is traveling, right? How far traveling. Multitude of ways again. So you can have distance, and distance is super easy. So you know, for speed and velocity, we had two variables. We had distance over time, but with distance, it's just one simple unit. It can be miles. It can be inches. You know, it can be meters. We're talking about a football field. It can be centimeters if we're talking about the distance a snail travels. It could also be kilometers. And like I said, it's just one unit. And we find that by looking for, and we're going to talk about this in a couple of minutes, but we look for distance by multiplying time times speed. And let's put a little cloud around that. All right, time. Oh, let me put a question around this. Time. It answers the question, how long? So how long are these notes going to be? How long is class? How long do we have till spring break? So seconds, it could be measured again in a multitude of ways. We have seconds. We have minutes. We have hours. We have days. We have weeks. You know, the list goes on and on, right? We have months. And we have years. Distance, you guys. Time is going to be distance divided by speed. And I'm going to show you a quick and easy way on how to solve these. As soon as we finish these notes, let's put a little bubble around that. Don't forget to put a bubble around the question that it's asking. And finally, acceleration. And if you know from our notes earlier this week, you know acceleration is anything that has a change in speed or velocity. Let me make sure you can see my notes. Speed or velocity. And let's put a little cloud around there. So, acceleration, also it can be miles per hour squared. It can be meters per second squared. We work with this one a lot, this unit. Basically, acceleration is increasing speed. Remember, it's a change in speed or velocity. So it can be increasing in speed, meaning the object is going faster. It can also be decreasing in speed. Decrease in speed. And then, of course, acceleration also means the object can be changing direction, right? Changing direction. All right. Okay, so eventually you're going to start calculating speed, velocity, distance, time, and acceleration, okay? So what we're just going to separate our paper. So eventually there's going to be a time where you start solving for speed, velocity, distance, time, and acceleration. So a quick and easy method that we've all seen before was the triangle, right? So we're going to take our pencil or a pen, whatever we're working with, and we're going to draw a triangle, and it does not have to be perfect, okay? You know, a simple triangle. And we're going to divide it up into 3 sections. So the first section is going to be distance. And I'm going to put capital D in parentheses. And then we have speed. I'm going to write that full out. And I'm going to put capital S in parentheses. And then we have time. And I'm going to put capital T in parentheses. So like I said, when you're looking for distance, speed, and time, I want you to use this triangle every single time, okay? So let's say we have a question and we want to find distance, right? So of course, if we cover up the D, it's telling us that distance is equal, in order to find distance, you need to multiply speed multiplied by time, right? So what we're going to do, we're just going to put a little multiplication sign right here in the middle. And that lets me know that in order to find distance, we're going to multiply speed times time. And then for my straightforward people, we can actually write this out. So the formula for distance is equal to speed, right, multiplied by time. So let's write that out. Speed times time. Now let's say we're looking for speed. Cover that up. You see that speed, in order to calculate speed, that leaves us with distance divided by time. So what I'm going to do is take my pencil And I'm going to put a little division sign right here. And again, for my straightforward students, we're going to write that out. Speed is equal to distance divided by time. And if we're looking for time, same thing, cover that up. I see that I'm left with distance divided by speed. So I'm going to take my marker again, and I'm going to put that little division sign. Please make sure you're copying this as well. So time is equal to distance divided by speed. Now, acceleration. I wish there was like a little easy triangle method for me to show you for acceleration. You just have to write it down. Don't worry, you do not have to memorize it because they do provide this formula for you when you need it. But the formula for acceleration, and I'm going to show you some examples of this, is going to be your final velocity, so capital V for velocity with lowercase f for final velocity, minus your initial velocity, capital V, lowercase I for initial, divided by time. Okay? So you have your formulas that you need in order to calculate speed, time, distance, and also acceleration. Make sure you copy this down. Go ahead. We're going to stop the video right here, and I want you to go watch part 2 because now we're going to take our notes and we're about to solve some practice problems, okay? Talk to you later, my kiddos.